Click the bell icon to get latest videos from Ekeeda.
Hello friends, today let's study one of the most important topic of solid state physics, that is crystallography. Crystallography basically deals with the geometry of the crystal structure. So let's begin. So let's begin to build crystals. To build crystal, take a crystal and slice it apart. Now we'll take one of the sliced part, and this sliced part is called as a unit cell. Now using this sliced part, you can build the entire cell. This is called as unit cell. So what is a unit cell? Unit cell is the basic building block of the entire crystal. Now Brevis, who was a physicist, used to imagine that atoms are present on the vertices of these unit cells, and this lead to the formation of Brevis theory of crystallography. So this theory basically deals with studying 7 Brevis lattices in detail. Let's study the lattice parameters. To study the lattice parameters, we'll place this unit cell on 3-dimensional Cartesian coordinates, of which x-axis, y-axis and z-axis are represented as shown. We'll label them as x, y and z. Now the length on the x-axis is shown as a, the length on the y-axis is shown as b, and the length on the z-axis is shown as c. The angle between x and y-axis is shown as alpha. The angle between y and z-axis is shown as beta, and the angle between x and z-axis is shown as gamma. These are the 6 parameters by which a crystal lattice is defined. Now, varying these 6 parameters, you can get ample number of unit lattice structures. Brevis, who studied these structures, came up with 7 different types of unit structures as shown. Now, as you can see, this is cubic structure, tetragonal, orthogonal, monoclinic, triclinic, rhombohedral, which is also called as trigonal, and hexagonal. Are there only 7 types of crystal lattice structures? No. There could be many more different types of structures. As you can see, there were 6 parameters to contribute towards a unit cell. But these are the 7 fundamentally most found unit cells in the universe. So, as you can see in the cubic cell, all the lengths are equal, whereas all the angles are equal as well. In tetragonal, all the lengths are not equal. The only 2 lengths are equal, that is on the x-axis and the z-axis. On the y-axis, the length is different, whereas the angles are same. Same as in orthogonal, wherein not all the lengths are same, but yes, all the angles are equal to 90 degree. The point of question comes, how is it easy to remember these? Well, for that, you have to switch to the next slide. How to remember these 7 parameters which defines the 7 different types of crystal structures? Well, for that we have a trick. So for this you need to memorize one of the mnemonic as shown. Remember this thing, CTORHMT. Write the name of the crystal structures in the given following manner. It stands for cubic, tetragonal, orthorhombic, rhombohedral, hexagonal, monoclinic and triclinic respectively. Now do remember one of the most distorted structure in the entire Brevis lattice is the triclinic, wherein neither of the sides are equal and neither of the angles are equal. So let's write it down first. In triclinic, A not equal to B, which is not equal to C, and also the angles alpha not equal to beta not equal to gamma, which is not equal to 90 degree. All the lengths are equal, A equal to B equal to C. Now as you go down, just distort one of the sides. As you can see, in tetragonal, I'll make A equal to B, which is not equal to C. And in orthorhombic, I'll make A not equal to B not equal to C. Now repeat the entire sides pattern. It would be A equal to B equal to C. Then I'll be having A equal to B, which is not equal to C, and then A not equal to B not equal to C. For angles, you need to follow a pattern. As in cubic, you have alpha equals to beta equals to gamma is equal to 90 degree. Well, in tetragonal and orthorhombic, the same repeats. As you know, alpha equals to beta equals to gamma equals to 90 degree. Similarly, alpha equals to beta equals to gamma is equal to 90 degree. So these are the three crystal structures wherein the angles are same, equal to 90 degree. This can be visualized in the previous example as well. As you can see, all the angles in cubic, tetragonal and orthorhombic are same, all equal to 90 degree. In rhombohedral, you need to know only one thing, that alpha equals to beta is equal to 90 degree and gamma is equals to 120 degree. For angles, you need to follow a particular pattern which says that in cubic, your alpha equals to beta equals to gamma is equal to 90 degree. Now, in tetragonal and orthogonal, the same pattern will follow. As you can see from the previous slide, that in cubic, tetragonal and orthorhombic, all the angles are same, equal to 90 degree. Similarly, so in tetragonal, alpha equals to beta equals to gamma is equal to 90 degree. In orthorhombic, alpha is equals to beta is equal to gamma is equal to 90 degree. Now, in rhombohedral, all angles would be equal, but they won't be equal to 90 degree. Now, in hexagonal, you just need to know that one thing, alpha equals to beta, which is equal to 90 degree, but angle gamma is equal to 120 degree. This is the most important thing that you need to know for hexagonal. Now for monoclinic, you just take this gamma from here to here. So it becomes alpha equals to gamma is equal to 90 degree and beta not equal to 90 degree. Well, this is a trick to recall and memorize the lattice parameters of the 7 types of crystal structures. Let's derive a relationship between the lattice parameter, molecular weight and density. Lattice parameter is nothing but as side length or edge length, which is abbreviated as A. Molecular weight is abbreviated as M and density is abbreviated as rho. We know the formula that density equals mass divided by volume. Density is equals to mass over volume. Now, we know that this is a cube, so the side is A, the height is A, and depth is A again. So, volume of the unit cube is A cube. Mass. Mass is the most important parameter for any crystal structure because mass depends on the number of atoms in the unit cell. Number of atoms which are present in the unit cell. We'll consider the number of atoms to be present as n. We'll take it a universal number. Now, we know that if I take m gram samples of any compound, it would contain 6.023 into 10 to the power 23 atoms. Now, I want to find the weight of one atom. So, of course, it would be m divided by 6.023 into 10 to the power 23. Now, this number is nothing but as Avogadro's number that would represent it as Na. So, m upon Na is mass of one atom. So, considering n atoms in a unit cell, so total mass of the unit cell would be equal to n times m upon Na. Well, now you have this mass, you have this volume, we can find the density. So this density would be equal to n into m divided by Na, the whole thing divided by A cube. Solving further, you will get n times m upon A cube times Na. Now, we are interested to find A. So, we'll take this A on one side and flush every variable on the next side. We'll be having A cube equals to m times n upon rho into Na. Taking cube root, we'll find the value of A as m times n divided by rho into Na, the whole raised to 1 by 3. This is the most important formula to find edge length of any unit cell. Now, using this formula, there would be many questions asked in your exams. We'll be doing one of the questions as. The question says, copper is found to crystallize in FCC structure. Now, if you know what an FCC structure is, the question says, copper is found to crystallize in FCC structure. Well, FCC structure is face-centered cubic. I'll draw a typical example of this structure, which says that if this is your cubic structure, eight atoms are placed on the vertices and 6 atoms are placed on the faces. Top face, bottom face, the side faces, the front and the back face. So effectively, the number of atoms in the unit cell equals to 1 by 8 times 8, because the atoms on the vertices will contribute 1 by 8 of the atom, and that are 8 in numbers, plus atoms on the face will contribute half of the atoms, and they are 6 in numbers. So eventually this figure would come out to be 4. So the number of atoms in the FCC structure equals to 4. Now we are given the unit as copper. Let's take the molecular mass of copper to be 64. We'll just assume it's actually 63.5, but for this example we'll assume the copper mass to be equal to 64. We need to find the edge length, which is A, of the unit cell of copper, given that the density of copper is 8.96 gram per centimeter cube. Remember this is given in terms of CGS units. You need to convert this into SI units. So basically 8.96 gram per centimeter cube equals to 8.96 into 10 to the power minus 3 divided by 10 to the power 6 kg per meter cube. On solving further, you'll get the answer as 8.96 into 10 to the power 3 kg per meter cube. Well, the only trap for the question is you need to make sure all the units that you use in the question should be of the same category. If you're using SI, switch to SI. If you're using CGS, switch to CGS, but don't switch over. Now, we know the formula as we studied in the last slide, as the slide length is equal to m times n divided by rho into Na, the whole raised to 1 by 3. So I'll be using the same formula. A is equals to m times n divided by rho times Na, the whole raised to 1 by 3. Now we just need to plug in the values and find the value for A. So this A would be equal to 64 times 4, because in FCC structure there are 4 atoms present in the unit cell, divided by 8.96 into 10 raised to 3 into 6.023 times 10 raised to 23. The mass of copper is 64. Always remember, mass of copper is always given in terms of grams. Always remember, molecular masses are always expressed in terms of gram. So you need to multiply a factor of 10 raised to minus 3 with the m, so it get normalized to SI units. On solving this, you'll get the value of A as पीछे अच्छा On solving, you'll find out the value of A to be 4.74 into 10 to the power minus 29 meters. Well, this question could come for around 2 to 3 marks at Mumbai University. Now, switching to the next question. Gold is found to crystalline in BCC structure. Now, BCC structure is a structure wherein there is one atom in the body center and 8 atoms on the edges. Now, the total number of atoms in this structure is the entire atom contributing as 1 in the center plus 1 by 8 share of 8 atoms. That would give me 2. So this is the number of atoms present in the entire unit cell. The formula is same, A equals to m times n divided by rho into Na, the whole raised to 1 by 3. That would be equal to 207 multiplied by 2 divided by density into Na, which is equal to 105 picometer. So it would be 105 into 10 to the power minus 12 meter. On solving this, you'll get the answer of rho, which is density. Thank you so much for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda.